In this chapter on probability, we're going to first begin our discussion of probability by understanding what probability is and then how is that relating to what we've been discussing so far. The first thing I would like for you to understand is that when we think about probability, probability is that likelihood of observing some outcome. So it's how likely it is that some event is going to happen. Most of us intuitively understand probability on a very basic level, which we're going to investigate right now. Here I have a simulation that's going to help us to maybe understand flipping a coin and that probability that we assume and intuitively understand, which is going to give us heads 50% of the time. So if I were to click this one time, you'll notice that it's flipping a coin virtually for me and I got a tail. If I flip the coin again, I got a tail. So this is just random. It's flipping the coin for me. Let's go a little faster here. Let's say that I want to flip the coin 5 times in addition to the 2 I've already done. So I'm going to flip it 5 more times. That gives me a total of 8 flips, or 7 flips, excuse me, and I got 3 heads out of 7. So right now I'm looking at somewhere around a 42-43% outcome, right? I flipped the coin and it only happened, I only got heads 43% of the time. Let's try that again. So I'll reset this and see if we can get better odds this next time. Now let's do it 10 times. So I'm going to do 5 times, and you'll see the simulation that is occurring here. And I'm going to do 5 more times so that I have a total of 10 flips. Now, in flipping the coin virtually for 10 tries, I got heads only 40% of the time. So what exactly is going on here? I thought intuitively we knew that if I flip a coin, I should get heads 1 out of 2 attempts. Let's see what happens if we reset this, and now instead of flipping 7 or 10 times, what if I were to flip a coin 1,000 times? What would happen then? So when I flip the coin 1,000 times, I end up with 514 heads out of 1,000 flips. So in other words, I'm pretty close to that 50% mark. Now, let me reset this and we'll look at it a different way. I'm going to change the screen, reflip my 1,000 attempts. I don't get the same proportion as I had a moment ago, but I still am at 49% of the flips that I did resulted in a head. And you'll notice here on my graph that we see, now I can start to see what's happening to the flips as I flip it more often. Notice on the left side of the screen over here, we're kind of bouncing back and forth. We have a lot of what we would call noise in the graph over here. And so there's a lot of variation that's occurring the smaller the number of times I'm flipping is. And then as I start to get somewhere over here, we're at, maybe like 175, something like that, 150, you'll start to notice that this line evens out and it's really close to that 50% mark, or 0.5, that we assume when I flip a coin. So the less number of times I've done it, we have a lot more variation. But if I can continue flipping this coin in the exact same manner for a very long period of time, you notice that I get closer and closer to that intuitive probability that we understand. This leads us to this idea of the law of large numbers. The law of large numbers states that as any number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the outcome. Now what that means is, the more times that we did the experiment simulating flipping a coin, the closer we got to what we assumed would be the outcome of our probability, what we intuitively understood the probability of flipping a single coin to be. So that's what the law of large numbers says, is that we're going to get close to that mathematical number the more times, the larger number of repetitions I take of that experiment, I'm going to get closer and closer to that value we're interested in. So that is our understanding of probability. Let's discuss some terms that are kind of important for us as we look at this idea. First, we have an outcome. Now, that's going to be the result of our experiment, whether I flipped a head or a tail. Sample space, we'll see sample space as all of the possible results that could happen in my experiment. So in the case of our coin flipping, our sample space consisted of either a head or a tail. And then the event is what I'm actually looking for, or that collection of outcomes from our sample space. So let's look at this example here. We're asked to take a coin and a single die, and it's a 6-sided die, and we want to know the likelihood of getting heads with an even number. And we're going to take this example to help illustrate some of these terms that we're looking at from above. First of all, we want to determine the sample space. So our sample space is going to consist of all the possible combinations of flipping a coin and rolling one die. So if I flip the coin, I'm going to get a head, and then I roll the die and I could get a 1. I repeat that process. I could get a head again, and then I could roll the die and get a 2. Flip the coin, I get a head, roll the die, I get a 3. I think you see where we're going with this. So each time I can flip the coin and get a head and roll the die, and I get one of the sides from that 6-sided die. So I have a head combined with the numbers 1, 2, 3, 4, 5, 6, indicating each of the possible sides from my dice. We are not done with our sample space yet, because remember, there's 2 sides to the coin. So for every time I flip the coin, I might end up with a tail, and then I'm going to roll the die and I get a 1. I can flip the coin, roll the die, get a 2. Flip the coin, roll the die, get a 3, 4, 5, and 6. These list, or this list that I have for us right here, is a list of all of the possible outcomes that can happen from flipping one coin and rolling a single 6-sided dice. So these are all of the combinations that can occur. And you'll notice that there are 12 different combinations. Then we want to talk about our event. Now, what I'm looking for here is I want to know how likely was it that I got a head and an even number. So we might say something like the probability of a head and an even number, where head and even number is the event I'm looking for, is going to happen. Well, if there's 12 possibilities for flipping a coin and rolling a dice, I'm going to put that in the denominator, and then I can look at my sample here, my sample space here, and I can highlight how many of those times did I end up with a head and an even number. I happen to have it 1, 2, 3 times, so there were 3 outcomes that resulted in the event I was looking for. So 3 out of 12, which is 1/4 or 0.25.